Hello everybody, welcome back to the channel. I've made something nice today. I made a program on a microcontroller with a display, and I can draw on that display. I can draw shapes on it using by posting JSON objects through HTTP. So it looks something like this. You see now the controller, right? And if I send a JSON to it, it will draw this triangle. So let's break down, go from the top and see what it takes to build this. So first things, let me get back to my normal screen. The hardware. The hardware is a Lilygo ESP32S3. It's a nice piece of kit. Cost about $27 now. I paid quite a bit more, I think, but I bought it early in the summer. Amoled display, so it's really nice and bright. Doesn't really come across on the camera, but it is pretty decent. It's an S3, so that means that's an extensor architecture. All the episode before I did on RISC-V board. The RISC-V boards are a little bit easier because they're supported by the regular Rust toolchain. This has a custom one. It's not too terrible though. There's a tool called ESP up that helps you manage the toolchain setup, and it takes some fiddling, but once you got it going, it works pretty much just as well as the regular Rust chain. So this unit, so how does it work? Honestly, I don't completely know. I'm not an embedded engineer, so I'll have to get lucky here and there. So there is some explanation here. If I zoom in. And the interesting part is around the top right here. It has some pins that are used to control the display. I can kind of infer what it means, but I don't really know exactly, but I got lucky because somebody else got a basic Rust version going. So that's this repository here, ESP32S3 Amoled RS. I did make a pull request to it because it was a while ago, it wasn't updated, and then the ESP HAL was out of date, and that would kind of make life with Embassy and everything I want to use a bit of a hell. So I didn't get any reply, so we'll see. But for the time being, I will use my own fork, so it will all work out. As a starting point, let's take the version I used before for using HTTP. So the HTTP server, the Pico server, that's a very simple HTTP server that runs quite nicely. I actually contributed a little bit to it with the author to make it a bit more robust. So that's that would be now. Before we're gonna do that, let's have a look at this repository because it has some nice pointers. In the source there is a bin folder with a few examples. And there's, for example, I don't know, like this one that shows a GIF of a crab, which is pretty nice. So let's see if we can flash those so we see if the hardware actually works. Let's go here. So we're gonna call the ESP flash. Oh, I need to enable the camera then. Yeah, it's still running the old thing. And I have to indicate which binary I want. So let's try. I just see the correct port. It uploads quite a bit faster than my C3s did. So maybe the cable is better, I'm not sure. So now we see the GIF of the crab walk back and forth. So that's pretty cute. I really like the look of it, and it's yeah, how nice and bright the display is kind of hard to see on the camera. It's actually kind of hard to film because I have to add some extra light, because otherwise the image will just be too bright for the camera. So that works. That is nice. I prepared a repository based on, let's see, right here, based on the API I made a few episodes ago to enable the HTTP server, so that we'll have PicoServe here. There's a new version. And what it basically will do, I'm not sure if I actually, I reorganized the code a little bit. I moved the network code, so establishing Wi-Fi, keeping the task going, into the net.rs. I put all the web endpoint based code in the web.rs, and the rest is still in main. So that's pretty straightforward. We set the general stuff up, and then we will set up the Wi-Fi, and then we run all the tasks. So nothing new here. So let's have a look to see what we need to do to get the graphics part working. So for that, let's have a look at the examples. I'll have a look at this one. This is the DMA, but the setup is pretty much the same in all of them. So we're gonna grab a pin, a bunch of pins, starting here basically. LED. So I think that one needs to be set high, otherwise the screen is off. So you can use that to, I don't know, save power if you want to. So we're setting that high. We acquire a bunch of other pins. We configure those pins. We create SPI, so that's a data interface towards the screen. Half duplex, because we're only sending one way. And we're using those descriptors for DMA, direct memory access. And then we create a display. So yeah, we need to do some configuration, set it to the orientation and everything. Then in this case they clear it. Let's run this demo as well, just to be sure. That was right here. That's DMA. Okay, yeah, you see it's very yellow. So it's showing, I can barely see it. So it's showing hello world, and it shows all the frames it did. And it does now, it's pretty nice, it does now nearly 100 frames a second. But bear in mind, it's only updating a very small part of the display, right? So the more you want to change, the more it will struggle. But it's a good place to start. So getting back to the code. So we had the display setup, and the way we use the display now is we create a style. We'll get to that for characters. We create a text object, and we draw it onto the display. So there's the draw function here, and you add in the display. Then it loops. It writes something to standard out, doesn't really matter. And it creates also a string that it will write on a certain location. So bear in mind that this screen doesn't clear on its own. It will just draw whatever you're drawing over whatever that was there. So if you're just gonna draw text without background, it will just turn into a blob, because it's like yeah, it will never show the background again. So that's already a pretty decent start, right? So let's start by making sure that our current setup is working. So I'm going back to this project that doesn't do anything with the screen. That's right here. ESP flash. ESP. And make it a little bit bigger. In the meantime, this is what I used to draw the image before. I had pretty straightforward JSON object, triangle shape type. I also have other shape types with 3 points A, B, and C with all X and Y. But now none of that is going to work because it's just a HTTP endpoint, but we can try to see if this works. And we just curl there and it says hello world. And that's what we expect because that's what the code said, right? That's in the web part. There is, let's see, we have a router. Oh. Yeah, we have a router that maps the root to a get root function, and that just says hello world. It adds connection close as a header, but it doesn't matter. It was just to debug. So that's where we are. First, let's get into getting that display to do something. So we have the I/O here. So let's copy in all the stuff from the demo that configures the screen. Where was it? Right here. So we have the I/O thingy, and from there on all this, setting the high, getting all this, getting all this, getting all this, getting all this. With DMA, display the works. Yeah, and include the hello world as well. Why not? So we're gonna insert that here. And then we're gonna go through a gazillion imports and everything. Master. I suppose. DMA priority should be somewhere. Nothing fancy. What else? What does it say? Weird, it doesn't show it as a quick fix, but okay. Oh, wait. That's in hell. Hell SPI master prelude. Doesn't it have that? Let's do this and see that will resolve. This one I will need to include the dependency for, so let's do that. And I need to add embedded graphics. Alrighty, so I do cargo add embedded graphics. That should do. So yeah, and I'll need to add that dependency anyway. So as I said, I had to make a fork. I really hope we can upstream it. because this one. So I will add this dependency. I think it actually should be released to crates. I don't. Oh, it's the wrong one. Because why not? But I would want to ask the guy who made it if he wants to do that first. So display Amoled RS. Git is this one. And then revision is something. Did I do something wrong? Okay, yeah, makes sense. But yeah, it would be nice if it was on crates.io, then it would be easier. Still building. Let me switch off the camera for a bit. There's absolutely nothing to see there. Doing a lot of building. So let's see if we can clean up the rest of the arrows here. There's a delay here. I think I need to copy that from the original as well. Yeah, this thing. Let's not make it harder than it needs to be. I'll put it somewhere around here. And then the rest should be imports, I suppose. More imports. It's actually kind of a problem, I think. This is the one we showed before on that demo. That is the largest font it really natively supports. So it's, but on this screen with the high resolution, it is still very, very small. My eyes are a little bit struggling with that. So it's, yeah, the high resolution is in that sense a little bit of a mixed blessing. But there are ways to actually render more complicated fonts, but I'm guessing that it will struggle a little bit with it. Okay, so got most of those. This one. This one. Okay, so no more errors. That's good. Let's see what happens if we flash this one. Oh, let me get the camera back. I'll drag up the console a little bit. Look at that. It says the hello world. I doubt if you can really make it out, but yeah, it does. Right? So yellow background, red text, hello world. So that is cool. And that's actually pretty easy, right? Now how to do the rest of this all. So one way to do this is to take the display object, make a static reference to it, pass it on to the web task, and just do everything there. I think that's possible, and it's for this particular case, I think it makes the most sense, just simply because that makes it easier. But I do think if you want to scale this project, or if you really want to make it more modular, I think we should put it in separate tasks, and the tasks need to communicate somehow. So what I want to do, first of all, is create a separate task that will do the graphics, because right now we draw something on the screen and we don't update it anymore, and maybe there is something you want to animate or something like that. So for that, it would make sense to create a graphics task, and we need to figure out how to read all the how to process the data, how to format internally the types. So what I would like to do is first create a special task for the graphics. So let's start by just adding it here, and that's an async function. We'll call it graphics, and it will take a display, mutable I suppose, display, and its type is let's see what it is. This is quite the beast. Can we well, at least let's get this one. The type, the lifetime, and the pin, I think. So let's continue here. That's like this. Static lifetime, because that's anything we'll pass to a top level task will need that. And that's then the pin. If I'm not mistaken, we can't use generics here. So CS is pin 6. And that's the output pin, I think. Yeah, it must be. So GPIO 6 with output, this output, and push pull. Does that compute somehow? I think one more. That did it. Import and import, and then we need to add the task, that one, and we can spawn it here. So spawner, spawn graphics, display I suppose, and unwrap. Does that work? There's something wrong here. It says descriptors doesn't live long enough. I guess we'll have to make that one static, because I think by inference it now made display static somehow. So let's see if that works. So we do use the make static macro around this one. Yeah, then we need to remove this. This one doesn't need to be mutable anymore. Fair enough. All right. So now we created the display, pass it in here, and now we can do stuff here. Okay, so next step would be to yeah, how do we want to define shapes, right? Because in Rust we really like to use types for those things. So let's create a new file, call it shape.rs, and let's include it so we have code completion. Mod shape, and then I think it makes sense to start with like a enumeration of all the possible types, right? So we start with, for example, enum shape, and that has some possibilities. So to keep it relatively simple, let's create a triangle. Named ones, I suppose. Point A has a we need to define the point. I could use this one. I'd rather make my own point, just to be sure. So let's create a struct point that has x as a u16, I suppose, and a y as a u16. Make them both public. And we have 3 points here for the triangle. Alright, so we have the shape. Now we will need some deserialization because we're gonna post them from the web interface. So let's do some deriving. Let's derive deserialize. And let's do a serialize as well, so maybe for debugging it's easier. And let's do clone and copy as well. They're pretty small. And then I think we need to do the same thing for point. Is this all we need? No, I think we need all of them. Okay, then we need to figure out how to get this from a request, because right now in our web state we let's see, we have the get here, and the get, yeah, that's not the one I meant. This one, get root. We don't really have access to the request, but we can create an extractor to do that, and that's what we're gonna do in a bit. But let's have a look first at how to do that. So we're in the, it's kind of debatable where you should put that code. Is it something that needs to be in the web part or in the shape part? But let's put it in the shape part for now. And there is a trait for that. Well, it's Rust, so there's a trait for pretty much everything. And that's what we're going to do, and that's called from request. That's in PicoServe for shape. And there are some things that needs. It needs a generic argument, and it needs a web state for that. I don't think I have a web state object here. I'll just start by making one. Pub struct web state with nothing in it. So we can call it web state. And then we need to add the method. The rejection needs a type. Oh yeah, we need to create a type. Let's, I don't know, we can make a struct, or we can make an enum. Let's make an enum for whatever could go wrong. So let's call it pub enum shape error. Not sure what will be in there yet, but that's it, shape error. What's wrong here? It's probably, oh, what's here? Okay, we need to implement that as well. So we need to be able to transform this one into a response. Let's do that first. So into response for shape error. So this is something. It's not. Let's create a variant, so at least we have something to call it, right? Let's call it I don't know, deserialization error with some kind of string as a explanation. So we can do this. Then that would be some kind of match here on self. And we have a deserialization error with a message. And that would be something like maybe a bad request, because that's status code. So we want to write that to the writer, right? So what are we writing? I think we need to make a tuple of a code and a message, and that's we can write that the response writer. To reference that, maybe, I don't know. Hmm. Okay. So then we need to do it as ref or something. No, to str. And then we need to await it. Okay, so it's a little bit clumsy, but it seemed to do the trick. So we create a tuple of a return code, bad request was 400 I think, and the explanation what's wrong, and then we write it to the response. But the nice thing is that once you have this here and you have all the variants implemented, you don't really need to think about it a whole lot anymore. So, where were we? We were talking about lifetimes. So I suppose this one needs a lifetime. Let's call it A. Alright. And I think then the whole thing needs a lifetime. Not here. Oh wait, no, it's wrong. This one doesn't need a lifetime, the web state does. And then we need to give it one. Let's see if we can work around it for the time being and get back to it in a bit. Because I'm not entirely sure where the problem lies right now. So this one wants a lifetime. Can we do it like this? Yeah, for now this seems to work. So now we're back to creating a request from a shape from a request. So what we're going to do, we're going to parse some JSON. I think the dependencies already had it. Yeah, there is Serde and Serde JSON is right here. Note that those do work in no standard as long as you have an allocator, because parsing JSON is kind of hard to do on statically allocated memory. You just don't know what you're going to find. Alright, so we have a shape here. We have the request. Oh, wait, what happened? Request, and we can get the body from that. And then we have a slice of bytes that will be the JSON. So we can call the JSON from slice with this thing. And create something out of that. So let shape type of shape equals this. Then that doesn't quite work because it will return an error or a result. So, but we need to return a different result. So we need to map the error. And I'm not sure what it is, but we will need to return whatever rejection is. Yeah, so let's just go to the shape error here. Deserialization error. With maybe there is something here. Does it have something like a message or something? Just let's do a toString. See if that does something. And then I think what's the problem? No, I think I just need to yeah, nice. So this will define that you can create a shape now out of a request object. And again, it's something that it's a little bit fiddly to get going, but once you have it's pretty easy to use, and I think that's quite powerful. So moving on, what else? We have a shape now. I think one thing to think about now is how are we no, maybe let's first create an endpoint for it so we can test this thing before we're going to integrate stuff. So we're going to go to web. We had this one, right, the get root that said hello world. Well, we can leave that be. Let's create a post shape. And the cool thing is here is that we can assert, we can create because we created that extractor, we can just say shape shape. Maybe need some imports, I suppose. So now we simply say that this one will need a shape, and otherwise it will return the error for 400. So what's a nice thing to do with it? Well, we can let's just do a print line to output, and we say shape was, I think I also implemented debug, so shape. I guess I didn't. So debug. That was in web. So now we have this one. It will say yeah, or we can return it. Let's do that. Format. Nah, let's leave it. It's not. And we call this hello shape to be sure that we notice the difference. Then we need to add it to the router. Where is it? Right here. Route slash shape. Post. And then is the post shape. That makes no sense. Okay, what's wrong here? So yeah, this is something that we need to do. What did I do here? I think I mean we're gonna need it anyway, but that web state I was talking about before, that's something that we'll need to deal with, I suppose. Okay, yeah, let's do that then. So the way it works in web frameworks like Pico, and it's similar to Exam, is that you can define a state object that kind of models whatever it is that is shared between requests. So if you have only totally standalone requests, life is easy, but it's pretty much never the case, right? So we need to create one, and that's the thing I made just before. Where was it? Oh yeah, web state right here. And then we need to serve it with state. So before we could get away with not doing that. But right now, let's say let mutable web state is web state. And it needs to be fancier, but for now it will do. And now this one is happy. So the sole reason we need it right now is that you need to add something here, right? So you need to have some kind of type you're going to define. I guess you can also do it with some empty type or whatever, but we're going to need it anyway because we need to send the shape somewhere. So let's see if that does something. I don't really think we're gonna need the camera because it won't do anything. Oh, I had the camera on all the time. I hope it wasn't in the way too badly. Anyway, let's go to Postman and see if this one works. It says hello. Oh, you can't see it. Sorry about that. It says hello shape. And that's kind of what we wanted, right? So we have here, we should have shape was triangle with the points. So now I'm just using the straight up derived deserializer. So it is kind of tricky because you have to really make sure that all of these things match the right field name. So there might be more elegant ways to model this, but this is a nice place to start. So we're going on for quite a while by now, so I'm gonna cut it here and I'm gonna finish it next time. Alright, so hopefully next time we can finish it, and I hope it's useful to you. I wish you the best for the holidays and the new year. I'll probably be back in a few days, and take care. Please leave a like or subscribe if you haven't, and yeah, again, let me know if there's something you're interested in or you just want to chat about something. I'm really interested to get more feel with the community. So take care, see you soon.